G'day Bifrosters, just a quick one tonight. I'm going to be looking at how to get objects in from Maya and not just your usual drag and drop it into the Bifrost graph kind of way, because if you watch this, it doesn't work. So we're going to have a real quick look at getting things in, specifically locators and then individual points on a mesh like we have here. Okay, so let's get into that. Here's the graph that it used to create it. I'm going to throw that away because it's pretty ugly, and I'm sure we can build a better one. So let's get rid of that, and we'll just bring this guy back here. So the first thing we'll do is the scariest one, which is getting some points in. The reason it's scary is because it involves a bit of Python, but don't worry too much, I'll give you the Python. I'll explain it as we go as well. So let's grab some vertex. Now there's the one, there's some I grabbed earlier, but let's grab some different ones. Let's go. No, that's not what I want. And like I said, we're going to need to do a little bit of coding. Now, don't freak out. I know it looks terrible, but it kind of ends there. And really, it's just this bit. So, we'll start with the scary stuff. This is the script that will allow you to get this into Bifrost. And here's how it does it. First thing, don't need that. First thing is it just imports the Maya commands, and then this is one of the most important lines. Yeah, put inside this variable a list of everything selected and list all of them. Don't abbreviate. Alright, so if we run that, and when this is always a good thing when you're doing Python scripting, you can check what's in your variables. So you can see that it's put a vertex in each one. It's a big list of vertexes. In fact, it's these vertexes, which is great, vertices. But it's not in the format we want. To get it into Bifrost, all we want out of these are its numbers, are the vertex numbers. So that's what the next line does. Oops, that's the wrong line. So this is just, yeah, the next line makes another string, which is everything in that string one by one, but split up so that we can get the numbers. So we don't want anything else. We don't want the letters, we don't want the brackets, we just want the numbers. So we'll run that. This is what our first string looks like, and our second string looks like this. And you can check 0, 0, 6, 6, 12, 12, 13, 13, etc, 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 etc. As I've commented several times, the order is very, very important, both in Maya and in Bifrost. The order that these come in will be the same order that they come into Bifrost eventually. So then we're just making an empty string, and we're running through this string one by one and adding it to the empty string with a comma. This is very, very important. So if you wanted to take a look at val string now, you've just got all of these numbers with commas in between them. Yeah. Then we don't want the last character, because the last character in this string, this very, very long string, is going to be a comma. There it is. So this just cuts off the last character. Now we put in the Bifrost board that we're using, which is this one. All good. This builds a dictionary that we'll look up later to build our string array, like that. I'll just move this over here for now while we do this, because the next command builds a Bifrost compound. So if we just have a look at our Bifrost, there's nothing in there right now. If we go in here and run that, you can see that a string's turned up, and right now it's an empty string. So this is just like the board, which is this variable here, plus a dot. This add node dictionary string. So dictionary is this, and string is this line. So it's building a command here and running it. And now what it's doing is it is putting our values into that. So into this compound here. There's our val string. There's our val string, if you remember what that looked like. It's just all the numbers with commas in between them. So if we run that line, you can see all of these numbers turn up in the name of the string node. And that's it. That's it. These numbers are now in Bifrost, and we can use them with this input. So I'll show you how to do that. So first off, I'm going to hide my sphere, and then I'm going to bring it into Bifrost. Now, this isn't going to work if you don't use the object that you got. the the points from. So just so we've got something to look at, I'll pop this out here. So the first thing I need to do is I need to make a list of positions. Let's do something to the position and the color, just so we can see. So we'll use my position in a normal node. There we go, we've all seen that before. And we'll use a new node I made today, just called create color array. And all this does is it makes an array of whatever default color you set it to, with the same number of points as is in the object. So it's really just a display thing. What I want to do is I want to get these positions and I want to push them out along their normal just a little bit so that they stick out from the surface. So I've got my verts, I've got my get positions. What do I do now? First thing I need to do is I need to turn this string into an array. String to array. And what's really handy here is I've got a string array, a float array, or a long int array. The long int array is what I'm going to want. Yeah, I'm going to take the normals, I'm going to multiply, and I'm going to multiply by a number, and then I'm going to add it back onto the position. So it's just a point displace, but it's all the broken up bits of a point displace. So just go value, and we'll get real clever, and we'll use two values. So we're going to use 0 for one, and we're going to use 2 for the other. So what I'm going to do now is I'm going to get from my normals array, I'm going to do a get from array. I'm going to get all of these guys in the get from array, plug it into the multiply, oops, like that. Then we'll just use the 2. I may not end up needing to use 2 values, so we'll just pop that in there for now because I'm not quite sure what I'm doing. And then we will set an array. And we're going to use these verts again that we got from our string. I'm going to put these values in here. So what this has basically done is it's taken all of the normals out here, gotten the ones that are coming from the string, multiplied them by 2, and then set them back into the normals. So now I should just be able to do a displace points, and I can plug this into my displacement vector, and there you go. It's pushed them out by 2. And you can do this with any set of points. If you really wanted to try, you could like grab a set of points or project a curve on the surface and grab the points of that, bring those points in and do things with them. But right now, this is just about getting in single points. There'll be others later. And we'll just do the same thing to the color. So I'm going to grab my color array. Let's just plug this in so you can see what it looks like. Put it after the displace points. We'll just play by CGO property. Plug this guy in and change the property to color. I'll just really quickly change my alpha so it doesn't try and turn itself inside out. So here we go, nice red one. So I'm going to need a value, and it's the same thing. The value needs to be a vector 4, like that. And let's make it a bilious green, because bilious is a good word. And it's just set an array. So we want to take this array, and we want to set all of these indices to this color. Get the indices from up here. There we go. So now you can see all of the points that we chose inside Maya. We've made them green. Oh, that's really hurting me. Let's do something like that. We've made them green, we've pushed them out. We can push them out a little less so they don't quite look so hideous. Oh, that's a little high, we're multiplying. 1.5. So you've got a little lip like that. Yeah. So from here we'll go on to getting in the locator and doing things with it. Okay, so let's get a little tidy. Just going to just make all of this into its own compound for now. We will call this points on the outside. There we go. I told you it'd be tidier. It's going to be tidier because I'm not going to hide all the mess in other compounds. It's the Bifrost equivalent to sweeping things under the rug. So now we need to get in the locator. Now if you think about what a locator is in Maya, it's essentially just a null. It's a null object. It's a point in space that carries rotate and scale information. So it depends what you want to do with it as to how you bring it in. You can bring it in a couple of ways. If you want just the position, then you can just bring in its world position. If you want all of its transforms, then you have to do it a different way. But I'll show you both and we'll just use one. That kind of works. So before you jump out of Bifrost to get the locator, yes, it's next the abandonment issues cat. You need to add the inputs that you're going to put it into. So I'm going to add two. I'm going to add just a couple of value nodes. My first one, I'm going to make a vector 3. This is just going to be our world position. So you can change the name of that. And let's do that so I can remember what it is. World position, yeah. And then for this one's a little bit more. Go to matrix, go to 4x4 matrix, floating point, like that. And this is how Maya and most 3D packages actually treat transforms. I'm not going to explain matrices here, mainly because I don't really understand them. I'm learning them, but I don't quite understand them. It's a gap in my knowledge. I'll get there, I promise. So we just plug these into the input and we do nothing else with them for now. Maybe give them a name. World pose and Xform matrix with a T, as that's how matrix is usually spelled. So now I'm just going to close down Bifrost and open up my node editor. And what I want in here, let's clear this. What I want in here is my Bifrost graph and my locator. And I only want their shapes, so we'll just clear them and add them back in. And then we'll just open them both right out. I pressed 3 to do that in case you were wondering. So if you have a look on the Bifrost shape, you've got a couple of things here. You've got world pos here. This is the world pos we set up, and Xform matrix, which is the other one we set up. And all you have to do to get a locator in is you can either plug in the world position, oops, it's a bit close, isn't it? World position 0 into the world position. If I just wait a second, that'll show you that it's an XYZ, but we're just going to plug it into the main one. Then world matrix 0 into the transform matrix. And it's in. It's done. We're done with the node editor. We can go back to Bifrost. So now there's data coming into these. What are we going to do with it? Well, what I thought maybe I would do is we'll use a little bit of a raycast, project onto the sphere, and see what we can do with that. So I'm not going to use this one. I'm going to put this up out of the way. I'll leave it there so you can see it's happening. But I'm going to use this one to start with. So we take our world position. Now because I'm going to do a ray onto the sphere, let's see what we need for that. Raycast. Get raycast locations. So we need the geometry, we've got that. We need the positions. Now we've got that too. And we need a direction. So this doesn't bring in a normal with it. What we can do is we can use the normals of the sphere if we want to, but they're all pointing outwards, so that's not really working. So we'll just do a little bit of vector math, real quick non-scary vector math, and we'll make ourselves a normal to look down for our ray. So we've got our world position here. What I'm going to do is subtract that. And I'm going to take the centroid and plug that into the right thing. There we go. You need the rebel pack for the centroid. If you wanted to make it yourself, it's fairly easy. I've got a centroid node that I can show you in another video. So keep an eye out for that. And I'm just subtracting the point from the centroid. Okay, so the point is this point here. It's three values XYZ, XYZ, representing this point, and the centroid is the center of the object, or the centroid of the object. So it's the average position of all the points. It's the easiest way to think about it. Okay? So what this gives us is essentially subtracting these two gives us a vector from the center of whatever object you're projecting on to your locator. And we can use that as a direction. So we'll pop that into directions. And like all locations, we can use a location scope like this, so we can get to see what's going on. So that wants a position, so we get our world position in here. And this immediately breaks, because this one definitely wants an array. So let's just quickly build an array of 1. No breakage now. And we're projecting onto our mesh, and we don't need the directions for now. Let's just get a terminal running. Just the diagnostic, please, and plug this in and see if this works. And it has. Or rather, it hasn't. It looks like it has, but if you have a look here, if I just push this up, turn that off for now as well. If we, that's the wrong one, if we grab this guy and make this guy a big fat arrow, you can see you'd expect it to have a ray hit here, and it doesn't. It ray hits in the center of the object in here. I'm not quite sure why it does this. So to solve this problem, what I had to do was make a node that added points in a loop. Instead of taking our world position straight out to everything, which for some reason it doesn't like, I need to run it through this first. So in here I'm going to say I want 1 point, and I want it at that position. And then I'm going to try and hook everything up. You see it's coming out as an array. So that goes into positions, and that goes into positions, and then we break because this is not having a good time with something. We might need to do a new raycast. So delete that. Do a raycast. We'll put in our geometry again. We'll put in our positions from our point add, and we'll put in our directions from here. So what I might do is I'll do the same thing over here just to get that into an array. I'll break that because that kind of wants an array there. We'll put the subtract into this node as well, make sure it's set to 1. Plug that into directions, that's much happier. And then we'll just put our locations back in here. Now you can see I've got an array and it's hitting fairly close to the surface. Let's just move that around a bit and see what we get. It is hitting the surface of the sphere. So the reason that's inset a bit is that we're going from the original sphere. We're not going from the bits we did earlier, the points from the outside, which was displaced. So if I was to change all of my sphere connections, so we go 1, and then 2, and then 3 up the top, please, it's so late. You can see it jumps back out to the surface. So this is our original sphere coming in, and it's been deformed here by what we did in the points from the outside. And now if I move this locator around, it should, in theory, yeah, you can see it lift up over that lip there. So it's taking into account the displacement we've already put into it. Drop down, drop up, down again, up again. So there's a bunch of cool things we can do with this. Probably the easiest thing I'll show you is what I showed you in the intro. I'll just put a bunch of points on it. So now that we've got our array, we need to sample where it hits on the sphere. We do that with a sample property node, like this. And this needs some things. The locations need to go in. And the geometry you are sampling the property from, which is this guy, it needs to go in as well. And then we need to change this to float 3, because it's a float 3, it's a position. It comes with point position. It comes with point position set as default. You can put anything in there though, normal, color, whatever you want to do. Okay, you can also set it to just get the actual point or interpolate on the mesh. I'm going to leave that on interpolated right now. Okay, so we now have a property. What I want to do with this is I want to do a get points and radius. And that property needs to go into positions because it's the point position. Again, we need the geometry. I should have made a pass node and tidied this up a bit, but hey. And then the rest of it we can set ourselves the radius. Do we just want a max number, whatever. From here, we have to make these locations into points again, basically. So this one, however, comes with the point indices, which is great because I can go back down here, just grab another one of these, drag it all the way up here, and get my points and normals array like this. And I can just do our old friend get from array. And this is just going to pull those indices out of that array. And from here, I can just do a point scope. This. I've got to make a point object, of course. Construct points into the point scope. And we'll pop this into the proxy. And now we just need to change some things on our point scope so that I like spheres. Spheres are nice for me. 0.1, I'm just going to make them white so they show up nicely on the red, and then I'll turn them on the proxy here. And now you can see we've got a radius, which comes from here, get points and radius, a radius of 2. We can up that. So a radius of 4. They're white because the point scope is, I'm just set to color and it's 111. And that's great. And now the nice thing about this is I can grab this locator and move it around. And you can see because it's sampling the point on the surface and then getting points in a radius around it, that this is pretty much exactly what we were going for in the beginning. You could do something like this. And you can do all kinds of things with this. You could bulge it out by the distance to that point, for example, and make a nice blister, or you could make it concave, kind of Death Star looking. But yeah, there's all kinds of things you can do. But that's essentially it. That's how we got in some points and how we get in some locators. So let's just clean this up and then I'll run you through both really, really quick. Really just cleaning up. I'm going to grab all of that, group it. It's going to leave the inputs out automatically, which is good because that's what I want. I'm probably going to get a lot of input double ups here. Yeah, the geometry is coming in about 15 times. We'll just call this locator in, and go in here and consolidate a bit. So we'll do a layout, make it nice and tidy. Just going to get one of these geometries. Why have I left this in the video? Well, because this is a good thing to learn to do. It's keeping everything tidy so that the next person who picks up your work, the next person that downloads your compound from the server or whatever, isn't faced with wondering why there's 30,000 different geometry inputs. So we'll put them all into a pass and that keeps them nice and tidy, and then we can just go ahead and delete these. So many geometries. And that's cool. And the matrix node, we didn't actually use the matrix node, but I'm going to leave it here so that you can see what's going on. Put the pass back down here and get some sort of nice look going through. There's our output. We didn't need that in the end, so that can go. So that's now nice and tidy. And if I just lay out everything here, that's also nice and tidy. So now here's just one more thing before we go ahead and do this. There's no reason I can't put 2 locators in here, or 7, or 350, or 16 joints, or anything that has a world position will come in here. So I could plug a cube in there if I wanted to move that around. It would do the same thing with a little bit of adjustment. Locators I just find really handy because they don't render, and I'm old, so I'm from the days where rendering used to take a very long time to do. Yeah, so let's really quickly run through what we did. We'll start with this band of dark around the outside, and then I will let you go. So points from the outside, let's give that a layout real quick. We had the mesh come in. There's the mesh there. First thing we did was all of that nasty Python, which I'm going to supply on the download, the Google Drive download. What that Python does is it gets in all of these numbers, which are the indices of the points we want. So I'm going to change that over to name display. And I'm going to just change that to indices in, and this can be mesh. So with these two, we've pretty much got where we want. The first thing we did is we changed the string coming in into an array, and I knew we were going to need the long int because we were going to be doing things back down here with normals, and most of the array work in Bifrost wants long ints, so yeah, real happy to use it. So from the long, first thing I did is I got the point normals, I got these indices from that array, multiplied them by a number, and then set them back to the normal array. So I've got, you see here, you've got normal coming out, getting multiplied, and being set back in the array by the same indices, which is what these two are. Then I ran a displace points with these new normals that we calculated as a displacement vector, and I pushed that out through into the output, and that's what gave us the push out. So you could see this by, if I went in here and changed that to 3, multiplied by 3, gets a lot fatter, or I could go 0.2 and it would go inside like that because it's a multiply of the normals. Alright, I can also go -1, it's going to go in even further, and you get the idea. So it's just really doing nothing but multiplying the normals for these normals only, and then resetting them in the array. That's how the point movement is done. And then for the point color, it was essentially just the same. We used a node that I made called create color array, and all that node does is it gets the point count of the mesh coming in, turns it into a long, makes a new array by using resize array with nothing plugged in, and then provides the default color, which I set to red as a default. Let's just close this out the way and get a bit more real estate. And it puts out the color array. And the color array is handy because you can dip in and out of it all the way down the graph. You can say, oh, I want to change that point to blue. I want to change those points to red or whatever. It's a handy display tool. It's also very good for visualizing very quickly any of the user data you want to put out to Arnold or anything like that. So you can use it to visualize floats. You can use it to visualize whatever you like. It's a really good thing. Okay, so from the color, the brand new spanking color array, which is all red at this point, we did the same thing, set an array. So we set this color, which is the dark red, to these indices in this array. And this array is the color array, and these indices are the same as the two that went up here. Pop that into a set geo color, and we output it. And that was it, we were done. We had used the points that we selected manually in Maya inside of Bifrost with just a little bit of Python pain, and I'll be giving you the script to do that. Alright, so that's the points from outside. This is the locator from the outside. This is this one. And you can see here how it quite happily handles that displacement in there. I can put that down there. And I mean, if I wanted to, I could tell it to only find the points that were that dark color. We could have a nice little eyeball animation going on in here once we softened that out. But anyway. So again, we brought in, I have to go back out for this, so here's our input to the Bifrost graph. We brought in the world position and the transform matrix of this locator, and we did that in the node graph, which I don't have up in here anymore. Node editor, there we go, you can see them here. So we've got the world matrix going into the transform matrix, the world position to the world pos. And these were two inputs that we set up by just making a new input like you normally do. That one's a vector 3, and that one's a 4x4 matrix. So once we had those, we had to use a little compound I've made called point add, which is really similar to the Houdini add SOP, which basically just runs it through an array this many times and adds points at whatever position you give it. At this point, I'm just giving it whatever this world position is. This, for some reason, makes it a lot happier when you come to do raycasts and properties and things. So I grabbed that. That's got our point all sorted out. Here's our world position, actual point coming in, and the centroid of our geometry. And the centroid is the average of all of the point positions in the center. I subtracted the centroid from the world position, put it into another one of these point add nodes just for safety because this file has been crashing all day, and then stuck everything into a raycast location. So I'm casting a ray on that geometry from this position in this direction. And you can see that ray there. It's the purple arrow. And the reason you can see it is because I have left a a scope in here somewhere, location scope right there. So that is just showing me. I can turn that off, and it turns off. I can turn off those two there if I want to as well. Change the size, all of that kind of thing. I just left that on there so we could see it, but it's always handy to have a visualizer as well. So once I was happy with my raycasting and it was hitting, and I got locations and all kinds of stuff like that, then we sampled that property, and the property we sampled was point position, so point position on the red sphere. Then we got points in a radius, and we can change that radius, so we can make that bigger or we can make it smaller, like that. We can say, look, I only want 8 points or 16 points or whatever. If I turn that off, it's just going to find all of the points in that radius. Okay, and then we just, because get points in radius, it does give you locations and you can sample them. Like if I wanted to find out what the normal was at one of these points, I could use that. But it also just gives you the indices of the geometry that you're sampling on, which is really handy, because then all I did was I got the point positions of the sphere, I got these ones, which are the runs that have been sampled and corresponding to those white dots right now, constructed points out of them, made them white and a sphere and a size, so made the white dots, and then output them, and we were done. That's how to get a couple of non-standard things into Bifrost, getting in points, getting in locators. Hope that helped, and I'll see you in the next one. Thanks.